In this lecture, we're going to learn about template type deduction and explicit arguments. What we mean by template type deduction is the mechanism the compiler uses to deduce the type it would use to set up our template instance from the arguments that we pass to our function call here. For example, the compiler is going to look at A and B here in our call to the maximum function, and it is going to notice that they are of int type. And then it is going to say, okay, you are calling your function with int types, and I see that your function templates takes 3 replacers in here. So I am going to replace these guys with int. And it is going to guess that from the call that you make here, there's no other mechanism to help the compiler out. This is really what template type deduction is about. And for the first example here, we are passing in int parameters. So int is going to be deduced. For the second function call, we are passing in double parameters. So a double function template instance is going to be generated. For the third call here, we are using std string parameters. So we are going to deduce a template instance that uses std string here. This is what we mean by template type deduction. But we have seen that automatic template type deduction can really have problems, especially if you pass parameters of different types. For example, if we call our maximum function here with A and C, which happen to be int and double type, then we're going to have a problem because this function template can't handle parameters with different types. Because the replacer is the same, the compiler is going to enforce that all the template arguments are of the same type. And the template arguments are going to be what you pass in here. So A and B must be the same. If they happen to be not the same, for example, int and double, you're going to get a compiler error. Now we're going to see that we can use explicit template arguments. And again, I want to make it very clear the difference between a template parameter and a template argument. A template parameter is what you have in your function declaration or definition. So what we have in our function setup here are template parameters. TA here and TB are template parameters. But what we have when we call our function template is going to be template arguments. For example, C and D here are template arguments. And we're going to be using this terminology in this chapter and many more chapters to come in this course. Make sure this is super clear. So what we're going to look at is using explicit template arguments. And what this means is a mechanism through which you can force the compiler to use some type to generate your template instance. And the syntax to do this is really simple. It is what we have here. We say maximum and we put the type we want to use to generate our template instance in angle brackets like we see here. So this is going to use double. So this is going to explicitly tell the compiler we want the double version called. And it's going to generate that, and that's what is going to be called by this call we have here. A good benefit with this is that now this is going to support template arguments of different types. So if we make the call like this, the compiler is going to see that, we are calling with int and double types because A is int and C is double. But it's going to see that you want the double template instance generated. Now the compiler will have the possibility to do implicit conversions from other types to double. And if this implicit conversion fails, then we're going to get a compiler error. So if you look here, for example, this is the example for that. We are passing in A and E, and A is int and E is an std string. We cannot do an implicit conversion from std string to double. So this is going to give us a compiler error. And this is really all template type deduction and explicit arguments are about. We can use these things to really make our code easier. Now that you have this understood, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working directory. The current project is template type deductions and explicit arguments. We're going to grab our template files pretty quick and put them in place. And after that, we're going to open this in Visual Studio Code. Let's drag and drop on top of Visual Studio Code here. This is going to open our folder and we can open our main CPP file. And set up our function template. Let's clean this up a little bit, and we're going to set up our function template. Let's type this out just to practice. So we're going to say template, and we're going to say type name, and we're going to say T. And if you want, you can put this on a single line, but I prefer to put this on separate lines. But let's show you that. So we're going to say T here, and we're going to say maximum, and we're going to say the parameters. They are going to be of type T, and we can pass them by value just for now. And after this, we're going to go in the body of our function template, and then we can return whichever parameter is the maximum. We're going to say A greater than B here. We're going to use our ternary operator. And if A is greater, we're going to return A. If B is greater, we're going to return B. And this is our function here. Okay, now that this function is set up, let's set up a few variables to really play with it. So we're going to include the string library because we're going to be using it a little bit. And we're going to go down in the main function and put in our few variables. We have A through F here. A and B are int, C and D are of type double, and E and F are of type std string. The first thing we can do, we can say auto max, and we can assign whichever is the maximum between A and B. And once we do this, we're going to have that maximum stored in max here. But what I want you to see is what the compiler does when it sees the code like this. The compiler has no other outside help to know the function template instance it should really generate. It is going to look at the types we have here, A and B. It's going to see that they are of type int. It's going to see that it can use the function template we have here, and it's going to use that and generate a template instance that is going to take int, and it is going to call it to get our maximum here. Again, we can prove this through the debugger. We're going to set up a breakpoint. We're going to go to our run tab here, and we're going to run this through our debugger. We're going to build our thing, and when we hit the main function, you're going to see that A is 10, B is 23, which is what we have here. C, D, we have our values N, and std string, because it is a compound type or a custom type, we can expand on this and really see more information about this. But we don't have enough tools to really understand this by now. So we're going to just to use this as a wrapper on our string information here. Now, we want to call the maximum function and see what was generated by the compiler. And we can step into this function because we have hit the breakpoint by now. So if we hit step into, we're going to step into this function, and we're going to see that it is an int function instance that was generated. This is enough for our purposes. If we change our call here to use C and D, we're going to generate a double instance. So let's do that. We're going to generate a double instance, and if we print this out, we're going to see this printed out. But we can use the debugger to really prove this, not that we know how to use it. We don't have to look through the terminal output window, but you can do that if you want. You can set up stdc out and print max here. You're going to see it printed out. So let's run our debugger. We're going to see the template instance that was generated through the debugger. We're going to hit the breakpoint at line 17 here. If we step inside, we're going to see the local variables for our function here, A and B, and we're going to have the maximum function to the top of the call stack, and you're going to see that it is a double instance for our function template here. Okay, this is what we mean by template type deduction. It is the default mechanism that the compiler uses to know which template instance to generate from your function calls. But as we have seen in the last lecture, this can be problematic. One way this can be bad is if you pass different types to the maximum function here. Let's pass in A and C, for example, or A and D. This is going to work equally well. You see that we get a compiler error because the compiler now, it sees that we are calling with different types, but the template parameters here are really of the same type. They should be of the same type because T is going to be replaced for a single type. So the call we do here is going to fail. And if we run this through the compiler again, let's do that. We're going to use GCC. We're going to get a compiler error, and it is going to say deduce conflicting types for parameter T, int and double. So it can't really know which one you want. You want int or double. The compiler doesn't know, and it is going to give us a compiler error. But now we're going to see a mechanism we can use to make this work. And that's going to be explicit template arguments. Okay, what we can do to do this, we can go down and put in our call. We're going to say auto and say result or max. We can call this however we want. We're going to say the name of the function, and we're going to specify the template type that we want generated for our function template here. So if we do something like this with double inside angle brackets here, we're going to be basically telling the compiler, please generate a double template instance for this call we are doing here. So if we pass in C and D, for example, this is going to give us what we want, and we can print this out if we want. So let's say max. Okay, this is going to work. If we build, let's build with GCC. Let's use that. The build is going to be good because we are passing in double arguments. And if we run this, we should see our maximum. Let's bring up a terminal window and Visual Studio Code here so that we can use that to see things running. We're going to clear and run rooster. You see that we have our maximum here. But using explicit template arguments like we are doing here is going to allow us to even pass different types for our template arguments. And for example, now we can change the first argument here to be A, which is going to be an int. And we're going to leave the second one to be D, which is of type double. Now the compiler is going to see that we're going to generate a template instance of type double, and it is going to know that it can do implicit conversions for the arguments we pass in here. So this is going to work if we pass an argument that is implicitly convertible to the type we passed in the angle brackets here. And let's debug this again to show you that we're going to generate a double template instance that is going to be called and give us the maximum that we print here. So we can run our debugger by hitting the green run button here. Let's minimize this so that we can see our terminal window, and it is down here. Let's grab it and put it to the left so that we can really see things printed out as we debug. We have hit the breakpoint here, and we have our local variables. You can look at this if you want. It is basically what we have in the main function here. But what we want is to step into this maximum function, and we're going to see the template instance that was generated. You see that it is of double type here. Okay, hopefully now you can see that even if we passed different values for our template arguments, I should say different types, because A is of type int and D is of type double, but we're not getting a compiler error. The compiler is going to insert implicit conversions from whatever arguments we pass here to the explicit template argument that we specified here. Again, the explicit template argument, like we are doing here using the syntax with angle brackets and putting in our type, is going to tell the compiler, please use this type and replace that for T in our function template here, and generate a template instance we can call to service this call here. And we're going to do implicit conversions basically from int to double because that's what we want. Then D is going to be of double type. We're not going to do any implicit conversion. Then we're going to call this function. We're going to return a double from it because that's our template instance, and we're going to print that out here. This is what is happening, and we can prove that a double instance was generated through our call stack here. We see the maximum function is taking in double parameters, and it's going to return double as our explicit template argument here. This is the syntax that GCC is using, but we know now that it is a double template instance for our function call here. Okay, if you're not happy with what we are seeing with the debugger, you can also use CPP Insights to really prove this. Let's open this up. We're going to say CPP Insights. Let's do that, and we're going to have it open here. Okay, we're going to erase whatever we had in here, and we're going to put in another piece of code. We have our maximum function, I should say template function or function template, and we have our call here, and it is passing different types, A and D. Remember the last time we did something like this by passing in different types for the template argument? This guy failed. It couldn't really generate a function template instance because the template parameters we have on top here specify that these guys should be of the same type. But now we are able to use different types as arguments because we have an explicit argument specified. Let's run this and see the template instance that is generated, and you can see that it is of double type. We basically replaced every instance of t here with double, and this function is going to be called to service the call we are making here. Okay, this is really all we set out to do in this lecture. I hope you found it interesting. The main message was template type deduction, a default mechanism C++ uses to know which template instances to generate from your function calls. But if the defaults aren't working for you, you can use explicit template arguments to specify the template instance you want generated. We are going to stop here in this lecture. In the next one, we're going to see how we can pass template parameters by reference. Go ahead and finish up here and meet me there.